All right, guys, here we are. We're going to be learning how to calculate the variance. We're going to understand what the variance is, how to calculate it, and I also want you to understand how the mathematical equation tells you what it's supposed to tell you. So the variance, basically, is a metric that is used to calculate the spread of the data. Basically, is how far away are the points in a database from the mean. Basically, if this is your mean and these are your points to the left and to the right, the variance allows you to see how spread out your database is. So mathematically, let's do a quick example here. We're going to be looking at the amount of hours a week that students study in my class. Here I had 5 case examples, 5 students. And the first thing that we always do is to plot this data. So here we had a scale of the number of hours in a week. And I'm gonna go and plot the hours studied by Peter, Laura, John, Chip, and Tom. All right. So the first order of business to calculate the variance is to calculate the mean, which you already know how to calculate. In this case, is 2.6 hours. The next thing is the variance. The variance is calculated with the mathematical equation that is displayed there at the top. So on the denominator, we had the sum of squares. Again, it's basically how different is every value to the mean. And we had to square that value because if we did not square that value, the values that are to the left will offset the values that are to the right. And as a result, the variance will become 0. Okay, so the reason why we square it is that we make all of the numbers, all of the differences non-negative. So we add all of the differences for all of the values, squared them, and in the denominator, we had n minus 1. The fact that you had an n minus 1 tells you that this is the variance of a sample. If it was capital N, this will be the variance of a population. All right? So again, in brief, the variance will tell you the average difference from all the points to the mean. So let's see how that metric is actually calculated. So let's look at the case example for Peter. So I know that Peter studied for 2.6 hours. The mean is 2.6. That means that the difference for Peter is negative 2.1 hours. I'm going to go and plot that at the denominator of my equation. And remember, you got to square that. I now do the same for Laura. So Laura studied for 1.8 hours and the mean is 2.6. So that means that the difference is negative 0.8 hours. And I do the same thing for John, Chip, and for my friend Tom. Okay, so that right there is the denominator of the standard or the variance. The next thing that we do is to calculate the denominator. So n means the sample size. In this case, we had 5 students, so that will be our sample size. So that will be 5 minus 1. And if you were to run all of these mathematical calculations, which are pretty straightforward now, the result will be 2.5 hours squared. All right, so that's where the thing becomes tricky with the variance, because the variance is a square, so it's very difficult to understand, interpret the variance. So there are a lot of information that you need to know to comprehend what the variance is. However, the variance is important to calculate because it allows you to calculate another metric that is more intuitive, which is called the standard deviation that we're going to review next. So that's right there how the variance is calculated. Again, just for us to be clear, the variance allows you to calculate the average difference from all of the points to the mean, and it's a metric of variability on any database.